a Sonos Play 1 smart speaker. So somebody brought this into our local repair cafe. So I brought it home to see if we can repair it, because sometimes we haven't got the equipment or parts at our repair cafe. So let's plug it in and see what it does. Let's grab a power lead, an extension lead rather. And that's about it. It does absolutely nothing. So I'll just unplug. Let's check that was plugged in properly. It's quite a tight fit. I assume we should get some kind of power light on it. Let's just check that we're getting power to the mains lead. $244, $245, yeah, seems about right. So the mains lead's fine. So obviously there's a problem inside of this. Let's get this out of the way for now. So let's see how it comes apart. Now I can't see any screws, so hazard I guess there's going to be something under here. And yes, there we go. I don't know if they're Allen keys or Torx. And it appears that they're Torx T10s, so let's remove those. Right, making progress, we'll get that out of the way. Got another little bracket thing here, we'll take that off. Right, that comes off like that. You can see the speaker now. I can see some bits of tape down the side here. And we seem to have some screws around the lid, so I'm going to remove those first. I'll just find a smaller Torx driver. And these ones seem to be a T8. And a couple of little cracks in here. I don't know if you can see that on the camera. There's a little crack in the plastic just here. And there's some cracks in the back as well there. You can just see them. Right, well that's the top part off. Let's try and undo this little connector here. There we go. So it looks like we might have to take this back part off, because that's where the cable goes into. So I wonder if we're going to take this tape off. Let's see. Yes, there's more screws under there. I'll put a bit of tape on one side. And I'm going to remove those two screws. Probably going to have to remove the tape on the other side as well. I don't know much about these, I've never worked on one of these before. So I don't even know how you operate the thing, so let's try and get that tape stuck on there. But I would assume it would make a noise or light up or do something, rather than just being dead. Right, looks like this might be sort of glued around the outside. I'll just see if I can find a screwdriver or something, see if I can prise this open. There we go. Actually aluminium that. Right. Let's just zoom down a little bit. Just get these screwdrivers out of the way. I think I'm going to have to undo that connector there. Right, so looks like we've got a small Wi-Fi board here, switch mode power supply, and that's where the mains comes in. So I'll unplug that. Let's see what else is holding this board in. There's another cable. Actually, I think it's just the Wi-Fi connectors there. They seem to be siliconed into place. Let's try a little bit of IP on that. I don't know if it's just bits of hot glue actually. There we go. Right, let's put the speaker to one side. And let's have a look at this board, and I can see something just down there. There's obviously something blew up down here. It's a bit hard to see because the metal's reflecting the light of the camera. Right, I'll see if I can get this board out. I think that's all the screws out of it. Just have a double check to see if I can see any other screws there. Just going to remove that little ribbon cable so it doesn't get damaged. Right, the board is free. Well, the bottom of the circuit board doesn't look too bad. Looks like the mains comes in here, goes through a bit filtering. We've got a bridge rectifier, and that looks possibly like the switching IC there, although there is an IC or something on the other side as well. We've got a little opto isolator for feedback. Right, I might have to get this under the microscope so we can see exactly what's going on around here. Looks like we've got a lot of this silicone goo everywhere as well, which might be a little bit of a problem. I might have to see if I can get some acetone or something on this to try and remove that. Right, I'll get the microscope set up and we'll have a look at this under the microscope, I think. Right, I've got the microscope set up. And it looks like it could be a resistor, because there's a resistor either side of it. And it looks about the same sort of size. I'll try and get some IP on it and try and give it a clean up. See if we can make anything out. Right, so it definitely looks like a resistor. And I would say it's the same value as those ones, because I can see a 1, then we've got a big blast mark in the middle of it, and then we've got a 0 there. So it looks like it's a 1 ohm resistor. Let's see if I can pick away some of this silicone. That capacitor looks like it's moving around as well. Just going to try some tweezers. Now, I'm not sure if that MOSFET may have exploded as well, because it looks like the corner of it's missing here. I'm not sure if that resistor's blown as well. Could just be discoloration off this one, but we might need to replace all three of those. Looks like that one's blown as well. Let's try a bit of IP and we'll just give that a quick clean. Right, let's see if I can get the meter in shot. Well, we do seem to have a short between that pin and this one. And that would make sense why those resistors feeding this MOSFET have blown if that's gone short, which indeed it looks like it has. It would have caused those to blow, and probably the mains fuse, which is just down here. So let's see what the mains fuse measures, which is across these two pins here. Yeah, open circuit. Yeah, I'm not a fan of these types of capacitors. It may be worthwhile changing those as well. Right, let's have a look at the other side of the board. I'll just refocus the microscope slightly. Just check this bridge rectifier. Looks like the bridge rectifier is short as well. Yep. Yeah, we shouldn't be getting a 0 ohm reading from there to there. So it looks like it needs a new bridge rectifier as well. Let's see if we can see what the switching IC is. It is a, I'm not sure if it's a TDD-AB or a 6751MR. I probably hazard a guess at a 6751MR. I think the rest of it doesn't look too bad. We still may need to check a few other components. Let's just check this diode here. Yeah, that seems okay. Let's put in a diode check. Yeah, okay. That's okay. Let's try these ones. Yeah, they're okay. I'm not sure about these little transistors or whatever. Let's there we go, that one's okay. Well, we don't appear to have any shorts there, so that's good. must be the power supply that feeds the switching IC. Looks like it goes through a couple of resistors there. Right, I think I'll order some parts then, and then when the parts arrive we'll fit them and we'll see if we can get this working again. So I've just noticed on here there's actually part of the board being blown away. So we might have to do a little bit of repair on that, or possibly move the resistor just along slightly for cleaning this bit of PCB mask off here. Or maybe to move this resistor just along slightly and solder it to here and to there perhaps. I think we should be able to sort that. So I thought I'd remove the faulty components just so I could double check the size of the resistors. Yeah, and I removed the blown MOSFET as well. But what happened was I thought, I'll just try checking just on the output side here. So if I just go into ohms here, and this should be the rectifier diode from the power supply. I go across that. We've got almost a dead short. Now these are the smoothing capacitors. So if I just go on the back of the board here, and they just come to this point here. I'll just refocus that slightly. So this is the back of one of the capacitors there. Again, dead short. So there's obviously more problems on this. So what I'm thinking about doing is hooking it up to the bench power supply and maybe injecting some voltage into here and using the thermal camera just to see what gets hot. Because I mean, it could be something like the Class D audio amplifiers blowing, it could just be a shorted capacitor, could be anything. It could even be that diode on the other side of the board. Like I say, I don't know yet. So I'll connect the bench power supply up and I'll get the thermal camera out before I order any parts, I think, because you know, it might end up that it could be one of the main ICs, in which case we won't be to repair this. But you know, if we don't know, we don't know. So I'll hook that up and then we'll come back once I get all that sorted out. Right, I've got the bench power supply hooked up, and this is the Kweets KTI W02 thermal camera that I'm using. Right, I'm just going to switch the power supply on now. Right, there's that there. I'll just switch it off. Let's see if that goes dull. I'm just injecting 1 volt at 1.5 amps at the moment. So I'll just switch that on again. And there we go. You can see that diode heating up. So I suspect it's going to be that diode that's short. Right, if you want one of these cameras, I've left some links in the video description. See, they're not bad little cameras. And if there's something else getting warm over there, let's just double check over here. No, so I think it's just that one diode. I'm going to pull that diode and then we'll try injecting voltage again and we'll see if we've still got a short or anything. Right, so I'll switch this off for the moment. I'll switch the bench power supply off. And I'll just put something under there a sec so it's easier to work on. I'm just going to use some low melt solder, I think. That's it, low melt solder, that's quite cool as well, if you've not used it before. There we go. And it's off. Right, Right, let's give that a little bit of a clean up. And we'll test this diode out. I'll just zoom out a bit. I'll just flip it over, that would be easier. Yeah, that's short. And that's short. Let's just see if I just disconnect one of these wires here if I've got shorts on the board still now. And it appears that we haven't. That's just the capacitor's charging up there. If we go into resistance, you'll see the resistance change as the capacitors charge up. Right, I think that's another component that I need to order then. So I wonder if we inject voltage into this, if the rest of it will actually spring to life. Use the bench power supply as the power supply. Let's just try that. I'm not sure what voltage this is supposed to be given out. The capacitors are rated at 35 volts. So let's err on the side of caution. And we'll just put 5 volts into it for now. I'll just adjust the power supply here. So I'll put 5 volts at 2 amp in and we'll see what happens. Let's grab the thermal camera again. Right. I'll just see if anything else heats up. And that will be a no. Right, excellent. Right, so I'll order the parts and that diode now, and then when all the parts come, we'll come back, we'll fit them, and hopefully it'll work. Right, all the new parts have arrived. I've removed the mains cap so it's a bit easier to access, and I also found that there's a 10 ohm resistor that has gone open circuit that comes from the gate of this MOSFET here that goes to the driver IC. So I bought a new driver IC and a new resistor to replace the resistor that's just down there as well, but I'll show you when I bring the microscope in. Right, let's get the microscope set up and we'll start fitting these components. So here's the resistor here I was just talking about, this 10 ohm one, and if I just measure it with the meter there, you can see we've got about 89k, and that should be 10 ohms. So I'm going to add a bit of flux and then remove this resistor. Just add a little bit of fresh solder to that as well. I think I'm going to use a bit of low melt solder on this. I don't want to use hot air on it with it having a capacitor right next to it, so. There we go, that's a bit easier. I'm just going to add a bit of flux and then just clean these pads off. Right, I'm just going to add a bit more solder to this pad and then try and put this resistor on. Just using one pad at first. Right, that's one side done. That's better. Right, see if we can get this new MOSFET in place. I'm just going to secure these legs up first and then heat the top up again, just to make sure it's got good contact. Right, I think that should do for that. Right, I think we'll tackle these 3 resistors now. Now I did buy some 1 ohm resistors, but unfortunately I think I got the wrong size. because they're a bit big to fit on here. And I don't have any other 1 ohm resistors, so what I have got is some 0.82, which I mean it's only like 0.2 of an ohm, so I don't think it's going to make that much difference. So I'm going to fit 3 of these to here, and I'm going to have to use this bit of the pad here because obviously there's a bit blown on that one. So right, I'm going to add some flux first and then start soldering these. I think I'm going to put some solder on pad first. I might have to bridge that with a bit of solder, that part. I'll just spin this around so I can solder the last resistor. Right, let's solder in this diode next. I'm just going to add a bit of flux. And there we go. I'll just give that a bit of a clean up. I think we'll solder the mains capacitor back in next. Right, let's do this bridge rectifier. I'm just going to solder 1 pin first. I'm just going to add a bit of flux. Right, that'll do for that. Let's get this new mains fuse soldered in. Right, I'll just snip off these excess legs. Let's fit this new switching IC. I'm just going to add a bit of flux first. I'm just going to add a bit more flux to that, and then I'm just going to go over those pins with the iron. I'm not quite happy with the way those have soldered. I'll try some more flux on this. I'm not quite happy with the way those legs aren't tinning. I just don't seem to solder those very good. Right, I'm just going to spin that round. Right, I'm just going to put some IPA on. And I'm going to use a toothbrush just to give this area a bit of a clean. So hopefully that should be it. Right, I'll get the microscope out of the way and then I think we'll give it a test and see what it does. Right, let's get this plugged in then. So I think I'm going to use my dim bulb tester, just in case this decides to go bang, which it still may. So let's put something underneath this slightly for the glare. I'm just going to zoom out a little bit. Right, I'll switch this off. Right, let's see what it does. Well, it didn't go bang, See if we've got any voltages anywhere. I wonder, have we got anything on these output capacitors? And no, we don't. Is there anything on the mains? Let's switch this on again. Oh, I can see smoke. I did hear something there, like the switch mode power supply trying to run, and then I just started seeing a whiff of smoke from there. So something was getting hot. Should unplug this a second. I'm just going to grab the thermal camera just to see if I can see what was getting hot there. I may have got some heat round here. I'm just wondering if there's something to do with that MOSFET, because I ordered this one from eBay, and I'm just wondering whether it could be a fake one or something, because I had some problems with some other MOSFETs that I ordered from AliExpress on I think it was a battery charger I was repairing a few weeks back, and it turned out that the MOSFETs I got were fake. So I'm just wondering whether it's something to do with this MOSFET here. Or if it could be a problem with the transformer, possibly. I'm just wondering if I can plug this in somehow. Well, I can get the thermal camera on it at the same time. Right, well that's getting hot down there, whatever that component is. Or is it something on the bottom of the board? It could be those two resistors. Yes. So those two resistors are getting hot, which go to the chip here. Now, I did order those chips from AliExpress, so I wonder if those are fake. I'm a bit paranoid about things being fake now. Right, I think I'm going to have a look over this circuit a bit more, round about this area, and then see if I can see what's going on. Right, I'm going to get the microscope again. I'm just not sure whether all of the pins have taken on this IC. It looks like the last pin there possibly mightn't have been soldered in properly. So I thought I'd have a look at some of the other ICs. And they seem really oxidised. It's like we're just in a little plastic packet. Just like that. But when you look at the condition of the pins on them, I mean, it's like this one here. I'll just grab the tweezers a second, I'll just turn it upside down so you can have a look. So when you look at the pins there, you can see they're all really oxidised, and I've actually tried cleaning these ones, they're worse than that. There you can see they're a bit better. So I'm just wondering whether these ICs are fake or not. Because they don't look very well looked after, let's say. I mean, look at the state of the legs on that. So I think I'll replace it. We'll see if it does anything different, and then I might have to try and get some ICs from a different supplier, because I'm not too sure on these. Right, we'll get this IC off. I mean, I've just tried soldering this IC, no one even solder. I thought I'd try and tin the pins first. And it's not even tinning the pins. Right, just try grinding these with the grinding pen, just to get them down to some kind of copper or something here. Right, I'm going to try and tin these. Well, they did tin that time. Right, I'm just going to see if those pins are soldered. Right, I think we'll try it again and see what it does. I don't seem to be getting a good feeling about this one, like. Oh, we'll see. Let's plug this dim bulb tester in again, and I'm going to get the thermal camera out. Well, those resistors didn't get hot that time. And the mains cap's full. So it appears that that wasn't switching at all then. I haven't got anything on the output caps. But there's voltage on the mains input one. So this power supply isn't running. I'm suspecting that these chips mightn't be right, you know. Right, I thought I'd just change the switching IC again, because I wasn't quite happy with those other ones, so this one looked a little bit better. I'm not sure whether they've sent a mix of ICs, because they all seem to have different factory codes on them as well. So let's try this one, see if it does anything different. So hopefully it doesn't explode. In 3, 2, 1. Well, it didn't seem to do anything. Let's just try the thermal camera again, see if anything's heating up. I think the only thing that seems to be getting warm is the switching IC. Well, I'm not so sure on this one. I'm not sure whether those are just a fake bunch of ICs that they've sent, or whether there's something else going on here. So I still haven't gotten very far with this. So I've been looking at the data sheet for this chip, and this capacitor here is across the power supply that feeds the chip. So I'm just going to switch it on for a moment and then switch it back off. And if I measure on this capacitor here very carefully, it's actually off at the moment, but if you notice, we can see the chip trying to start up and then it shuts down again. And I've measured the voltage on the gate pin, which is this pin here, and it doesn't get triggered at all. I've not seen any voltage being produced on this pin. So to me, it looks like the chip's getting voltage, but then it's detecting some kind of condition and shutting down. So let's wait until this capacitor discharges a bit. I've still got 180 odd volts in there, so So then I started looking to see where it gets its feedback and that from. So we've got a pin here, pin 2. It seems to go to this opto isolator here. One of the pins is grounded and the other pin goes through a 100 ohm resistor and then into pin 2 here, and that seems correct. So the only other pin that it gets feedback from is this pin here, which is pin number 6, and that's to do with current limiting. Now we've got a small resistor here, resistor 178. This side of it's ground, and when I measure it across, I think we'll get about, I think it was about 100 odd K maybe. Let's see if we've still got voltage in this capacitor first. Yeah, it's dropping down there now. Now you can see that changing when the chip tries to start up and then shuts down again. So I think the chip itself is actually working. And if you notice now, because the voltage has dropped below the 22 volts, which I think is what its run voltage is, it's stopped cycling. So I'm fairly sure this chip's working. It's just not happy with some condition it's getting. And I think it might be this resistor here. I'll just try and turn this around a little bit. Just try and get it back in shot. Right, let's go into ohms and we'll measure this resistor. And we'll get about 80K. So I had a look to see if I could find any more information on this chip, whether there was a circuit diagram, and I came across a post on a forum where somebody else was repairing one of these, and they said R178 had exploded and wanted to know the value of it. And somebody had posted saying it measures 150 ohms in circuit. Well, this one doesn't measure 150 ohms, does it? I mean, that's the only problem with these resistors, because they're just plain black, there's no markings on them, so you don't know what value they're supposed to be. I mean, you know, if you're measuring that and you got a resistance of it, how do you know if that resistance is right or not? So what I'm going to do, I'm going to see if I can find a resistor the same size as this, but measures 150 ohms. We'll try fitting it and we'll see what happens. I'd be curious to see what it measures. Just like that. Let's see. Let's see if I can focus that a little bit better. Well, it looks about 250K. Well, I couldn't find a 150 ohm resistor. What I found is 100 and 47, I think it is. Right, I'll put some flux on this first, I think. Right, I just want to double check that I put the right resistors there and not picked up one of the broken ones by accident. Which I think I might have done. Because that one's 100 ohms and that one's measuring K, so I think I've put the wrong resistor there. Right, let's see what resistance we've got now between those two. Let's go into this pin here. And we've got about 150 ohms, which is what it said in that post. Right, I want to give this a clean up. A bit of IPA here. Right, I'll get the microscope out of the way and I think then we'll give it a test and hopefully it doesn't explode everywhere. Right, just going to plug this in. Well, it didn't explode, which is good. Do I get any voltage on these output capacitors? Oh. Maybe. Yes. I think that's it. Oh. I'll just turn this back on. Let's just see what we get on the mains cap. 320 and 24 volts. Excellent. Right, I think I'll just wait for that discharge and then I'll start putting it back together. Right, this should be discharged now. Now we're going to try and remember how it went back together. It's just been a few weeks since I even looked at this thing. Put this back in. I just took that out so I can... That was easier for testing. Zoom down a bit. That metal screw left, but I'm not sure whether that goes... Yeah, I think that goes on the bottom, doesn't it? Right, it's going to be a bit awkward to put these two cables back on. These two little Wi-Fi antennas. Now I get some hot glue and put some hot glue on here. Right, the glue gun's just about hot, but what I realised was I had these two antennas round the wrong way. It shouldn't make a lot of difference in any case, but I might as well put them back the way they were. Right, I think that should do for that. Let's try cooling that down a bit. Right, I think I'm missing some screws though. Or maybe not. Might be missing one screw. Right, I'm going to get the top part. Now, found the hidden screw. Was stuck to the bottom. Right, let's plug the power lead in. Well, I can see a white light on there, doing something, flashing. I don't know what a flashing white light means. No? Well, it made no. Well, it made a noise and now it's flashing red. Well, I guess that means it's trying to connect to Wi-Fi or something. Well, I would say it's working, but I haven't got a Sonos account or whatever, and I don't know how you make one, plus this one isn't mine, but it's no longer dead, so I think we'll call this one a fix then. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.